The topic again is mensuration. The last time we talked about mensuration of two-dimensional shape, which is plane shape. Today we are talking about mensuration of three-dimensional shape, and they are called solid figure or solid shape. You can then measure it in terms of its length, its breadth, and its height in three dimensions. And that's why we call it the three-dimensional shape. And the first shape we are going to consider today is our cube. A cube, you can see the height, the breadth, and the length. Though in a cube, all the sizes are equal. So the length, the breadth, and the heights are equal. They are all x. So that will lead us to three ways by which we can measure our three-dimensional shape. One, we measure in terms of its perimeter, which is moving around object, and then its area, which is the space occupied by that object. Then we can measure the volume, which is the capacity of the object. Now for our cube, we have this now to show our cross section of a cube. So that means a cube consists six smaller squares, six squares, 1, 2, 3, 4, 5, 6, and all the sizes are equal. All the sizes of these six are equal. So this perimeter, which is moving around the object, is going to have 12x. How? Because the height, we have 4 of it equal to x, the breadth 4 of it equals to x, the length also 4 of it. So that's 4 plus 4 plus 4 to give us 12x. And I said earlier from the cross section earlier, you can have this first square, which is x times x squared, second square, x times x squared, third square, x times x squared, fourth square, x times x squared, fifth square, x times x squared, sixth square, x times x squared. So we have the area of a cube to be the first cube area, the second cube is area, the third, the fourth, the fifth, and the sixth. So that will give us 6x squared. Whereas the volume of an object of any shape is the base area times its height. And the base of a cube is also a square, that's x squared. The height is also x, like I told us earlier. And the volume for our cube is x raised to power 3. The next shape we are considering now is our keyboard. A keyboard, it has its length, its breadth, and its height. Its breadth, its breadth, and its height. So in a keyboard, like a room, your classroom now is in form of a keyboard, like a room. You have this side, which is the length and the breadth, two of it. This side, which is the length and the breadth, 2, and this other side, which is the length and the height, 2 in a keyboard. So the keyboard has 6 rectangles: the first rectangle, the second rectangle, the third rectangle, the fourth rectangle, the fifth rectangle, and the sixth rectangle. Now, moving around the object, like I said earlier, it has 4 lengths, 4 breadths, and 4 heights. So when you factorize that, you have it at 4 into bracket L plus breadth plus height. Same way for the area, like we did earlier. Since you have 2 length and breadth, so it will be length times breadth, 2 of it, then length times height, 2 of it, then breadth times height, 2 of it. So that's how we got the area. 2 of it having the length and breadth, 2 having the length and height, 2 having the breadth and height. So when you factorize, you have the area of your keyboard to be 2 into bracket LB plus LH plus BH. I said earlier also that the volume of every shape is the base area times its height. So since the base area of your keyboard is the length and the breadth times its height, so we have the volume of our keyboard to be length, breadth times height. The next shape we are considering now is our cylinder. You have a cylinder, your can of milk, your beverages, most of them are in the cylindrical form. So you have the radius, which is from the center to any part on the circumference of the circle, and then the height of that cylinder. So how do we calculate it? It's not possible for us to calculate the perimeter, but we can find the area. And now we talk about the cross section. Look at the cross section. We have two circles and a cylindrical face. Can you see? A cylindrical face. It's round, and then the other side. So we have two circles. Now we can decide to cut this cylindrical surface from the side, which is the side of the height, side of the height. So when you cut, you have something like this. So you can cut and stretch out. When you stretch out, let me tell us again, or remind us again, that this part is the circumference of the circle in our plane shape. So when you stretch out, you are stretching out the longer part. And that part is still the same thing as the circumference of a circle. And that's why we have it as 2 pi r. The height is by the side where the cutting was made. So we talk about this now to have our curved surface area. I was talking about the curved surface of that cylinder. And if you go back to the shape here, you see, let's assume this is our length, because this looks like our rectangle. So if you assume this is our length, so the area of the rectangle is length times breadth. So this is our length and this is our breadth. So that will give us the curved surface area of our cylinder, which is 2 pi r times h, to get it as 2 pi r h. Now, to get the total surface area, that simply means the two circles will also be involved. So the area of the first circle is pi r squared. The area of the second circle is pi r squared. So when that is added to the curved surface area, and that's why we have the total curved surface area of a cylinder to be curved surface area of the cylinder plus the area of the two circles. So that will give us 2 pi r h plus 2 pi r squared. So when you factorize that, you can then have it as 2 pi r into bracket h plus r. Volume, like we said, base area of any shape times the side. The base area is pi r squared. Sorry for this two, it's not supposed to be there. Pi r squared times h, and that will give us pi r squared h, pi r squared h. Then the next shape we are considering now is our cone. Our cone. Look at the cone. We can also cut out the vertical height, that's h, and then from the center, the radius, and then this side is called the slant height of the cone. The slant height, we can calculate the perimeter, but we can also cut up to show the cross section, like we said. We cut that off, look at it, the circular part, the circle, that's the base, and then this other part. This other part can then be cut from the side of the slant height. When you cut it from that side, you open this, and automatically the radius of that portion being cut out will have is going to be our slant height. It has its own circle. Note this, because we are going to make mention of that later. And the circle from the base is also there. So when you have that, you can then begin to talk about the area, and then so you have that to have it as curved surface area as pi r L, pi, then the radius times the slant. But we'll move a little bit further. I said we can cut out the triangular part, which is, can you see the triangle? And that triangle can then be determined. Any of those sides can be determined using our Pythagoras theorem. So that's the triangle from the cone. This is the height, this is the radius, and that's the slant height. That's our slant height. So you can use your Pythagoras theorem to calculate any of these sides if they are not given. Then if the angle, the vertical angle is given, you can also use that even in getting the vertical angle. But how do we come across this? I'll still go back to explain how we come across it. Mind you, the length here is also the length of a sector. And there's a formula for that, which is the length of a sector is what? Theta over 360 degree 2 pi r. So, but the r here will be the slant height. The r here will be the slant height. And this length is the same thing as the circumference of this circle. So when you equate that, some things will cancel out. Some things will cancel out. 2 will cancel out. Pi will cancel out. Then we have theta over 360 degree L, which is the slant height, equal to radius. So theta over 360 degree will then be equal even to r divided by L, the radius times the slant height, which was then substituted. Because what was substituted into our formula, because when you consider the area, it's a sector, it's an open end without the circle, and it is a sector. The area of a sector is what? Theta over 360 degree pi r squared. Mind you, the r of that cone is the slant height of the sector. When you substitute theta over 360 degree here, then it will give us this formula, which is pi r l. So note, I'll still bring that up later. Then the total surface area is the core surface area of the cone plus the area of the circle. That's the core surface area of the cone. Then area of the circle. Since the base of that cone is circular, is going to, so you factorize that to have the formula. Then the volume, the volume, the volume of any object is the base area times the size. I said earlier that the bottom, that's the base. So that looks like a cylinder. But because we know the volume of a cylinder is pi r square h. So a cylinder having the same height and the same volume as that of a cone, 3 of that cone will fill the cylinder. And that's why the volume of a cylinder is divided by 3 to have the volume of a cone. I told us volume of a cone. Note, I told us this earlier to determine the angle of the sector from the curved surface area of the cone, then we can have it as theta over 360 degree 2 pi. That was what was substituted into the area of the sector to give us pi r square h. The next shape we are considering now is our pyramid. We have a square base pyramid. This is the base, these are the base, and the height here is the perpendicular height. This side is the slant height, not the height of the cone, because sometimes students are asked to determine the height of the cone and they trace this here. No, that will not give us the real height. We must trace it to the slant height, so it must be traced to the slant height, meaning we must look for the diagonal of this base, and then our height is just at that center. So it will be traced here and you come out with a right angle triangle, which you can, well, that will be a question for around that time. Now we have again the rectangular base. Can you see you have the length, breadth, and its perpendicular height, length, breadth. We also have a triangular base, but we don't have that here. But now I want to talk about the cross surface area of a pyramid. Look at it, a pyramid, just like your Maggie star. If you're familiar with that Maggie cubes, okay, this is what you see, like your Maggie star. Can you see now? So the cross section is going to be, if it's a rectangular base, that means the length and the breadth, then the 4 triangle, the rectangle, and the 4 triangles. If it is triangular square base, the square, and then the 4 triangle. That's it. Then formula for finding the area now. Area will now be area of the base plus area of the triangles, the 4 triangle. And that's why we have it as area of the base. If it's a square base, can you see b square times 4 into bh. If it is rectangular, area of the base, which is rectangular, times, you have 2 of those triangles that has base and then the height, 2 of those triangles also that have length, and then the height. So you have it 2 into bracket half hb plus 2 into bracket half hl. For the volume of the pyramid is, like we said, the base area times its height. Just like I said earlier concerning our cone and our cylinder, the same way a square base, something that's a cube, a square base will be a cube. So for a cube now, the volume of a cube and a square base pyramid, 3 of that square base pyramid will fill the cube. And that's why we have it 1 over 3 b squared, because the height will most likely not going to be equal to the side. Then for a rectangular base, you have it 1 over 3 BLH or LBH for the volume. Now the next shape we are going to talk about is our sphere. The sphere is, you can see it now, like your ball. As a sphere, we play football, like a football is a sphere. How do we get the area? The area of the sphere is 4 pi r squared, whereas the volume of the square will give us 4 over 3 pi r cubed. Now we talk about the hemisphere. That's cutting the sphere into 2 parts. And for your hemisphere, you can see like a bowl, so to say. Can you see the radius? That cross section can also be seen when we remove the upper parts. When we move, if you in Nigeria, you see the Hausa ladies when they are going to get married, they have these baskets. They design for them to put their beads. So there's a covering, and that's a circular covering now. And the hemisphere, that is the hemisphere. You can now find this like a bowl where you can pour out something. Now, how do we calculate that? The core surface area is half of the area of your square, which is dividing 4 pi r square by 2 to give us 2 pi r square, whereas the total surface area will be the area of the Earth's curved surface plus the area of the circle, and that gives us pi r square. And that's why this pi r square is added to give us 3 pi r square. Then the volume is just half, like we said, half the volume. So when you divide 4 over 3 pi r cubed by 2, you have this as the volume. And in summary, we also have a pyramid, which you can also find the prism, which you can also find the volume. And the volume of a prism is going to be the base area times its height. Also, we can be asked to find the area of the prism, but it depends upon the shape of the prism. Now, some prisms are triangular in shape, some are rectangular in shape, and some are just a square base prism. So now you have to open up, like find the cross section, and then find those parts that are involved in the shape, and eventually add up to get the area of the prism. See you again in the next class. I am Adeyemi Alao. Thank you for being part of my class. I advise you to subscribe even to my YouTube channel. Bye.